So, ladies and gentlemen, on behalf of the Association of Geospatial Industries, I am pleased and excited to welcome you all to our knowledge session on the role of geospatial technologies in forest management. Today, as every year on March 21st, people worldwide observe the International Day of Forests to recognize the value of forests and promote forest restoration. More than 1.6 billion people, according to a UN estimate, are directly dependent on forests for things like food, medicine, housing, electricity, and livelihood. India happens to be one of the world's 17 mega biodiverse regions with a long term goal of having 33% of its land under forest cover. It is a myth that the best approach to maintaining a forest is to leave it alone. Active forest management is now more crucial than ever. Climate change is resulting in higher temperatures, widespread genetic erosion in the forests is already happening, and tree populations and species are becoming more vulnerable to overharvesting, deforestation, and forest fires. We will all agree that the key to effective management of forests depends on having access to timely, trustworthy, and accurate information about their condition. Geospatial technologies help do exactly that. Geospatial data is key to enhancing the capabilities of not just decision makers, but also field and community stakeholders, giving insights into the various aspects of forest management and planning. Ladies and gentlemen, today AGI takes this opportunity to disseminate awareness about the role that geospatial technology can play in sustainable forest management. I am pleased to share that we will be joined today by central and state government officials, forest departments, researchers, professionals, entrepreneurs, academic experts, and students. We have with us an impressive lineup of industry and academic experts who have been working in the field for years now and will be sharing their insights with us as part of today's panel discussion. We have with us Dr. Om Prakash Martuni of the Indian Institute of Forest Management, Bhopal, Dr. Ruma Chakrabarti from ESRI India, Mr. Mukesh Verma from IIC Technologies, Mr. Partho Ghosh from Planet, and Mr. Yashwant Singh from Satpalda as our esteemed panelists. On behalf of the AGI Secretariat and all our attendees today, I would like to extend my warm welcome and thank all our esteemed panelists for joining us. This panel will be in a Q&A format, and I also welcome the attendees to drop in their questions in the chat box so that we can take them up towards the end of the session. With that, I would be introducing to you our first panelist of the day, Dr. Om Prakash D. Martuni, Assistant Professor, Faculty of Ecosystem and Environmental Management, IIFM Bhopal. Dr. Prakash has been serving at IIFM since 1994 and was previously associated with the Forest Survey of India, where he worked extensively in the area of remote sensing and GIS applications in forestry and watershed management. He has been instrumental in the development of the national set of criteria and indicators for sustainable management of natural forests in India, which have been duly incorporated in the National Working Plan Code of 2014. Dr. Prakash, my first question to you is a little generic, just trying to set the context of today's session further. If you could please throw some light on how the meaning and relevance of forest management in India has changed over the course of the country's history. Over to you, sir.
Yeah, thank you very much. I once again wish you all this UN International Day for Forestry, that is the Forestry and Health this year, the theme. Rightly observed that even the theme itself is mentioning about that how this sector has now been emerging, or rather going with a very fragmented and scarce resources. So like forest, like other resources, it is also vulnerable to various anthropogenic and climate-induced pressure. It is subjected to various kinds of threat, which includes the deforestation and degradation, as we are all aware. Now the impact of this deforestation and degradation, And also another important aspect which sometime overlooked and not a time to now to overlook, that is the impact of invasive species, because this is the one area which basically this species is outcompeting all the native species and altering the basic structure of the forest. That is, I'm talking about geomorphology of the forest, which includes the composition of the forest, even the change in the forest types, which includes the biodiversity and the various ecological functions. And climate change has rightly observed, which can be seen due to the various what is called that the wildfires, impact of wildfires in burnt area and its impact again on the ecosystem services of the natural forest, etc. So this is besides that we are also talking about the immense pressure due to the unsustainable harvesting, because this unsustainable harvesting which yields to the overexploitation and the fragmentation of the forest ecosystem and also directly challenging the natural habitat of wild species, which includes both fauna and flora. And over on that, the sector is reduced to with very handful of people, which basically calling for more and more involvement of the community and their participation in forest management. I'm talking about how the sustainable forest management be achieved through the involvement of this what is called that communities through that and all these things. So when the resource becomes very scarce or the fragmented, technology play a very vital role. Now the forestry sector, it is no more going to be, or at present, going to be an independent sector and working in a silos or in isolation. It is a sector now actually working with a lot of integrated approach. So hence the technology also playing vital role, and geospatial technology become an important and integral part of today's forest management. So hence, when we talk about the today's forest condition, forest management, though globally says that one third of the what is called geographical area is under permanent tree estate, that is the nomenclature accepted globally. In our country, we call it as a forest and tree cover. But if you come to the country here, what we call that, that it is a very difficult to answer that when we talk about the forest area and cover, because that in our country we are taking any area, geographical area which has more than 10% tree cover as a forest cover, which itself is biased, because globally they say that 30% forest tree cover or more is considered as a permanent tree estate. So here something actually, some of the issues, like if you take that very dense forest of the country, which is something around 3% of the area, where when we talk about the globally, which is called a classification which is trusted as a forest cover, forest or a tree cover. This is some of the issues I think we need to pursue with this state-of-art technology like geospatial technology, with the change detection, continuously monitoring, spatially as well as temporally. These are some of the issues which need to be addressed as you take the, because India has a very diverse forestry condition if you compare to the global forest. Even if you compare with the Asian forest and forestry as well as Indian forestry, something actually we talk about the growing stock or the forest cover or the biodiversity, though we are the 17 mega biodiversity uh, of the world, but same time we should not forget that we have two hotspot area, biodiversity hotspot area. It means that that major what is called that the biodiversity area like Western Ghat and the Northeast area, it itself is indicating that 50% or more of its natural habitat has already been lost. So this is what I want to propose initially. So welcome to have more questions. Yeah, thank you.
Sorry, I was on mute. Thank you for highlighting some of the key issues before the geospatial sector that probably our tech experts and innovators can answer in the coming years. So thank you for setting the tone. We would now move on to our next panelist, Dr. Ruma Chakrabarti, Divisional Manager, Urban Pre-Sales, ESRI India. Dr. Ruma has over 20 years of experience in the corporate sector with comprehensive experience in a turnaround of information technology across different platforms, including GIS, ITMS, e-governance, system integration, and so on. She has tremendous experience in working on geospatial technologies, business intelligence, planning, and geography. Dr. Ruma, forest planning is one of the most important aspects of forest management, shedding light on the future of our forests. What role do you think can geospatial technology play in this regard?
I
Dr.
think
Ruma, you're on mute. If you could unmute yourself. Yeah.
Good afternoon, everybody. Regarding this, as it has already been spoken, that climate change is a very emerging challenge for us. It's an emerging disaster for us, and forest will obviously play a very crucial role in mitigating its impact. GIS enables the foresters to create databases that are crucial in preparing the work plans, wildlife conservation, as well as the soil conservation. Broadly, the GIS covers the following roles. It acts in the field of terrain analysis, site suitability for recultivation, updating the forest inventory, different species, mapping the biodiversity, mapping the different types of administration in forest, like protected forest, which are the JFM forest, which are the other type of forest. So this type of, and then forest cover type discrimination in different type, in terms of its species, in terms of its coverage, in terms of its this climatic zones, forest climatic zones. Then we can also map the flora fauna details of the forest using the geospatial technology. Then, as professor has mentioned, that mapping the forest fires. So forest fires are an emerging problem in many parts of the country, and which is also going to play a very crucial role in climate change. So mapping the forest fires through geospatial technology is one of the very important component. Then wildlife management. So we know that we are counting on the different type of fauna inside the forest, and that can be used through geospatial technology, like radio collars they put around the different types of big cats, and that can, their locations can be tracked, their habitats can be mapped based on that. And then most important thing, which is still, although it is coming in practice, but still it is a long way to go, is the working plans for the for the forest cycles. So if we know, forests are divided into working cycles, blocks, and then compartments. And the working plans work in two ways. First is the geospatial location of resources, market price, etc. And second is the complete decision making. And geospatial technology especially provides the topographic data sets, the vegetation data sets, the economics of the forestry, because as Sakshi has mentioned, the livelihood components of several peoples are also dependent. So that has to be also taken care. The social and the administrative data sets for the different type of thing. Then we need the growing stock data set. So how the forest is growing, the girth, the density, the crown density, etc. All this can be provided by geospatial technology. And finally, the decision making set. Decision making me in the sense that which are the best suitable area where we can go for the replantation, where what type of actions need to be taken for the prevention of forest fire, or the for slope stabilization, etc. And in economic domain, we looks into the species diversity, what is there, the age of the different trees, the size of the timbers, the timber diversity and volume, so that we can specifically plan for where the felling has to go on, where we need to grow the new forest, and how we can take. So it is a diversity. There are several components. soil, geology, forest, terrain, etc., coming into this forest, sustainable forest management. And that is how geospatial technology is going to play a part in that.
Thank you so much, Dr. Ruma. We now move on to our next panelist, Mr. Mukesh Verma, Assistant Vice President, Sales, IIC Technologies. Mr. Verma is an engineering graduate with over 15 years of techno-commercial experience in the geospatial industry, primarily responsible for handling the business development activities across several industry verticals by promoting the use of latest GIS technologies for data acquisition, processing, and data analysis. He has a strong passion towards learning and implementing the latest geospatial technologies and brings vast experience in handling large-scale national projects and effective project management towards end-to-end GIS solutions for various applications, including forest management. Mr. Verma, so far we have had a broad overview of the various issues for forest management in India and very broadly the kind of applications that geospatial technology can have in the field. To you, I would like to ask a more specific question, a more technology specific question. If you could please throw some light on the benefits of using LiDAR as a technology for vegetation density and forest biomass analysis. Over to you.
Thank you, Sakshi, and a very good evening to all the participants and the co-panelists. Thank you for this opportunity given to me to share my few thoughts on the usage of geospatial technologies for forest management. So, Sakshi, just coming to your question, yes, very specifically, you've pointed out about the LiDAR technology. So, I would like to focus more on what are the key benefits that this LiDAR technology can give us in terms of accurately creating a base map or the complete data sets of the forest related features. So the key thing in any of the data analysis would be to have highly accurate and precise data sets. That forms the fundamental base layer on top of which you can carry out several analysis and several mapping can be done and can be used for several applications within the forest itself. So this aerial LiDAR technology using which we acquire the data, we will be able to accurately capture the laser point cloud of the forest canopy. And the advantage of this technology is that now, unlike the other photogrammetric or remote sensing technologies, we will only be able to see the top surface of the forest, which is the canopy. Whereas in LiDAR, the laser pulses which are emitted, there are about a million laser pulses emitted per second, and these go and directly hit the various levels of the forest area. It can be the treetop, the mid area of the canopy, as well as the ground. Several points, the laser pulses will hit the ground and reflect back. So thereby the advantage is I can get very accurate digital elevation models, which can be created using the LiDAR point cloud. And the advantage is, along with the laser, I also can acquire high accurate and high precise resolution aerial imageries along with the LiDAR data. Both would be having the same timestamp. And these two data sets can be accurately used for carrying out several analysis. Now, in the most common threat actually in the forest is that so there is a lot of floods that are happening. Because of the flood, what is happening? The soil parameters get disturbed, and because of the floods, there are these land degradations, landslidings that are happening, and we are unable to mitigate or manage the water effectively, right? So when we are talking about the forest, so if we are able to create a very good base layer of the entire forest map by creating a very good high resolution digital elevation model, so we would be able to clear the entire surface of the forest. So we can classify the entire LiDAR data into various groups. So we can classify the entire tree cover area and then derive the bare earth model, using which we will be able to generate accurate contours. And using this data, we will be able to create the good drainage maps, the water runoff studies, and also a good catchment area map can be derived. And we can plan suitable locations for constructing water recharge structures. And so this would help us in also, conservating the soil parameters because of the soil erosion actually. And we'll be able to construct soil conservation structures locations also will be able to precisely identify using this technology. And the advantage of this technology is it gives us accurate data, and it is also very cost effective when compared to the other technologies. And it will save a lot of time and energy, because certain things manually we cannot do, and we can cover large areas using this technology. That's the advantage this LiDAR technology has got. Thank you, Sakshi.
Thank you, sir. That was
Yeah.
most illuminating. Now, moving on to our next panelist, Mr. Partho Ghosh, Pre-Sales Director, Planet. Mr. Partho is the Pre-Sales Director of Planet for India and South Asian countries. He provides technical expertise in driving business opportunities. He has 16 years of experience in multispectral, hyperspectral remote sensing, SAR interferometry, geoanalytics, and drones with various global organizations like ESRI, PCI Geomatics, etc. before joining Planet. He is an alumnus of the International Space University and has several publications in national and international journals and conferences. Mr. Partho, my question to you is, what kind of insights can satellite data reveal for deforestation? And how can this data be leveraged for better management and planning of our forests by various stakeholders? Over to you.
Thank you, Shakshi. Respected dignitaries, very good afternoon to all. Yes, satellite data can reveal a range of insights related to deforestation. Firstly, forest cover changes. Only satellite data can provide the regular basis, the accurate data about the changes in the forest. Maybe that change, it may be the change due to the illegal logging, change due to the some different kind of maybe for agricultural expansion, or in the name of ecotourism, some development activities are there. So all kind of change on day-to-day basis can be captured, and that insight can be extracted from satellite imagery. Dr. Om Prakash mentioned about the fragmentation of forest. Yes, that is another biggest problem. There's a fragmentation, and satellite data can reveal the changes in forest fragmentation, which can impact ecosystem health and resilience, as Dr. Om Prakash already mentioned here. Sometime we can identify the forest loss driver. Forest loss driver means we can, like as I mentioned, as illegal logging, agricultural expansion, infrastructure development. So that can be the different driver for forest loss. So that can be identified in right time so that it can be prevent or it can be allowed. Forest carbon stock insight generation. Yes, that can also be, which is very much important for understanding the role of forest in the mitigating the climate change. So these are the forest deforestation related change can be identified and can be used here. Particularly for forest management, we have other options also. In the forest management on day-to-day basis, we can monitor and enforce the forest protection. For example, some forest deforestation happens. So, and where the risk of deforestation is there, that can be identified on day-to-day basis, and it may be sub-daily basis as well. So that can be identified, and accordingly, as per the policy, the protection plan can be applied, and protection plan can be implemented. We can improve the land use planning as well. For example, as I mentioned, that is the conservation. We can prioritize the conservation. So expansion of agricultural activities or sustainable agriculture will be allowed or not, or will we restrict the constructional or infrastructural development, or we will allow. So that can be planned properly, and policymakers can go accordingly. Sustainable forest management can be managed using the satellite imagery data as well. Satellite imagery or remote sensing data It is not only satellite imagery or information regarding the forest can be gathered through drone also or through aerial survey as well. So any remote sensing data can be used. But as Professor Om Prakash already mentioned, that is a spatially better data and temporally better data is also very much important. For example, some forest fire or some deforestation is happened today or it is started today. And if I get the information after 10 days or if I get the information after a month, what will happen? So deforestation is already done. We cannot do anything. Forest protection cannot be done. So right data, right time with right spatial resolution is very much important. Specifically for forest fire, it is already just early detection of the forest, prediction of the forest fire or detection of the forest fire, behavior of forest fire expansion along with the wind direction and all, and post-fire assessment can all be done using the satellite imagery or remote sensing data. Maybe optical, maybe uh, synthetic aperture radar, or maybe LiDAR. So all these things can be done using the satellite imaging. So satellite data can provide the valuable insight for managing and protecting the forest as well as preparing for the responding the forest fire as well. So that is my views on deforestation and satellite imagery. Sakshi.
Thank you so much. Thank you, sir. With that, we move on to our next panelist, Mr. Yashwant Singh, International Business Specialist from Satpalda. With about 10 years of experience in the geospatial domain and having worked on many photogrammetry projects, Mr. Yashwant has a deep understanding of 3D data sets for various applications. With an education background in the domain itself, he has been working directly towards correlating the theoretical aspects of the technology into its real-world implementation. Mr. Yashwant has also worked closely on a forest project where Satpalda created a decision support system for the forest department. Mr. Yashwant, we understand that forest management planning is a very delicate process because there are several environmental, economic, and social factors at play that need to be considered. How can the integration of 3D landscape assessments and GIS help to study all these factors and pave the way for more effective forest management? If you could please throw some light on it.
Yeah, of course. Thank you so much, Sakshi. A very warm good evening to all of you. A very warm namaskar as well to co-panelists and all the participants in this session. Thank you, AGI, for conducting this session. It is very important to know the role of the latest technologies in the forest management. As the question was about the use of 3D landscape into the forest management. First of all, forests are the big areas, so we need to have that technology which can acquire the bigger area in one go. So that is the answer which Partho also addressed. It is the use of the satellite imageries. They are very effective, not only the optical, but if you're using the SAR, if you're using the LiDAR data set, they all are very useful. So the very first thing is that the high resolution satellite imageries will be used for that, for the forest management. As far as the geospatial technology is concerned, the second is we need to acquire the data set in the form of the stereoscopic data set so that we can create the three-dimension model out of those imageries. So once we create those three-dimensional models out of those imageries, we can derive the further products out of them, which are called the 3D landscape data sets. So what these data sets are actually, they are giving you the elevation information at each and every pixel of the imagery, that you can have the elevation information at each and every area of the forest. Number one. Number two, we can analyze the slope as well, as Ruma was also discussing about the importance of those slope for some particular species they're required. So you can analyze the slope once you do have those 3D landscape with you. They are called the digital elevation model or digital terrain model. You can see we can generate the contours out of them. We can analyze the aspect out of them. So once we do have these terrain models, so they are also giving us the information about all those man-made and the natural features which are there on the ground and which are responsible for a better management of the forest ecosystem, like the streams, the condition of the ponds, and what was a scenario in the past and what is the scenario in present. We can do it with the help of the temporal analysis of the data. So this is how the 3D landscape plus remote sensing data sets or the satellite imagery can help. The temporal analysis is one thing. Another is by processing of those data sets, we can calculate the biomass of the green areas. We can check the health of the vegetation of the trees, and we can figure out those things. And GIS and remote sensing not only helping in the analysis of the terrain, the geomorphology of the terrain, but it is also helping in analyzing sometimes if there is some encroachment happening in the forest area. So with the help of these high resolution satellite data sets, we can detect those encroachments. We can demarcate the forest boundaries very easily because we do have that vast coverage with us. One more thing is about the use of the web GIS platform for the forest management. As Sakshi said, that we at Sapalda done a project for the Kerala Forest Department, where we created an application, the web GIS based application, which in turn used as a decision support system for the department itself. So what happened there? They have integrated all of the data sets they do have, like the climate data, the rainfall data, soil data, DEM, and the other drainage systems. Plus, they combined it with the different tree species. So with the help of these data sets, they are able to find out that which species is suitable at a particular climate, at a particular slope, which species will be good. So these slopes can be analyzed, these drainages patterns can be analyzed, the watershed can be mapped with the help of these stereoscopic imageries and with the help of these 3D landscape. So this is how the 3D landscape can contribute into the forest management, Sakshi.
Thank you so much, sir. Dr. Om Prakash, coming back to you. We always say that forests are the biggest source of food and fuel for the world. But we also need to ensure that our forest resources are managed in a more ecologically sustainable manner. So, what role do you think can remote sensing, GIS, and other geospatial technologies play to assist this kind of vision?
Okay, well, as I initially mentioned that now, so when the resource becomes scarce, technology play a very vital role. That much is sure, whether it is forest or any other resources are concerned. As I mentioned, this remote sensing, this is something actually gives you the continuous set of data. That we should not forget that, because having continuous set of data itself is a strength in the forest management. As you are aware, for example, I give you one phenological aspect in the forest. You know that the forest type in India, or the forest species composition, or the morphology in forest morphology in India, in comparison to the temperate forest or something like that, this is something actually challenging itself. Because in a forest, I did certain study for the student as well as for in my study. If someone imagine the number of tree species in a forest division, I tell you, it is not less than 70 to 80 tree species. Each species has its own phenological characteristic. So hence continuous set of data is very important. I give you an example. For example, that you have mentioned about the fuel and fodder or any other NTFP circles. I give you one example like Anjan. Okay, this is one of the important fodder species in the central India. Okay, so this is being invariably harvested wherever it is found in the forest. But if you see the phenological characteristic of this particular tree species, unless you understand this and apply it in the remote sensing, these are some of the two end of using the technology in the forestry. When you say that here, you're coming to the fuel wood, for example, okay? Fuel wood is the bona fide right of the community who are residing in the vicinity of the forest. It is their bona fide right, right? But only the law says that they can only take out the dead and fallen wood from the forest for their self-consumption, not for marketing and all these things. Now it comes to the technology in itself to regulate this particular bona fide right, right? So remote sensing, as you know, that it is something actually giving you the spatial aspect and all these things. But when you use the GIS, that is the ground data or the sample data or the community data and all these things, important here is to regulate this particular rule. Then there are crucial area where you have to have a surveillance system. In this remote sensing and GIS together play a very vital role. How it happens? You know that when we have the forest assessment, which includes both canopy as well as stem density, etc. I really appreciate if the cost effective this 3D what is called 3D photogrammetry or the photogrammetry application is accessible to every department. I think nothing better than that. Believe me this, because this multispectral image may not serve the real actual use of remote sensing technology in the forestry. That is my experience. Even hyperspectral image certainly help us, especially to a particular area which I experienced while using this hyperspectral image. It has its own constraint too, like without having what is called that the reflectance, what is called library or the reflectance data, that is spectrometer data. It is very difficult to used by the nominally used by the technology expert. But it has overlapping band. It has its own disadvantages, advantages. Advantages is that nominal data can be used to have continuous observation and having a nominal data set in the forestry, which is, I think, somewhere good at the state level or at the divisional level. When you come at the watershed level, I think probably this is not of that much use, though the Sentinel says that they are providing 10-meter data, etc. But even though but now after this Sentinel data, what I observed is that even this overlapping data is very useful because they are providing very high temporal resolution data, which is very useful. As you say that the fuel, that is the fuel wood or the NTFPs or the fodder, etc. This high temporal resolution data is very useful to allow the community to collect the fuel wood in the forest. Because, for example, that after knowing the phenological, after knowing its what is called that the having the regeneration or having the age of the forest and all these things, so which really help to allow the community or earmark the area for their fuel wood activity. Which one small study I conducted, that how to ensure the bona fide right of the community while earmarking the forest, which is very easy if you use this kind of high resolution data just by mapping the age of the forest or the stem density of the forest and also phenological characteristic of the fuel. This is very important because unless you regulate the fuel wood collection time, it will really harm the regeneration potential of the forest. That is very important. And same time, this collection of this would also help the forest. Sometimes ecologists may disagree to that collection of the wood or collection of the dead and fallen material in the forest is against to the ecology or against to the biodiversity of the forest. It also helps. Why it is helping? You know that this climate change, because of the continuous drought period or continuous dry period, is increasing the forest fire situation. You know that in our country, hardly any forest fire is natural in nature. They are mostly accidental or intentional in nature. But I mean to say accidental because ignorance sometimes creates forest fire. accidental, sometimes people campfire or cigarette or the bypass or something like that. No? So this high combustible material needs to be regulated. I give you one example from the Chhattisgarh. Like that we all aware of the fine needles, what is called the vulnerability posed by the fine needles. How Chhattisgarh overcome to that fire needle. It's a very beautiful case. That they have pursued it with the charcoal making with the SHGs. And because that it has a very low biodegradable potential naturally, this final needles, unless you manage it, I think it will have a very good combustible material for the forest fire. So that is how this what is called the fresh needles are being collected by this community to produce because it cannot be used directly because it has a very low what is called that calorific value and very high combustible material. So converting them into char and charcoal and use it by the community really a sustainable approach. Similar thing in the forestry also. There are a lot of invasive species. This needs to be uprooted and used solidified or make into a sustainable fuel like briquetting or something like char briquette or the what is called the biobriquette, we call the white coal or the charcoal. So this geomorphotic technology will give us that what are those areas which is of invasive species as a policy, now implementing the policy. If you cut this species and it will come back again. When you earmark it to the community, uproot it and use them. So gradually what you are making reducing the invasive species or the extent of invasive species in them. So like this remote sensing technology, these are few of the example without taking much time of the others because I'm actually believe in understanding more from the experts rather than I tell my things. These are the two area I giving you as a case example. Certainly this technology helped even in earmarking the area for the fine needles, fresh fine needles, use it for the charcoal making or the invasive species, which is something actually unwanted thing in the forest, to uprooting them, earmark them, uprooted by this community to convert them into a useful biomass for their energy, meeting their energy requirement. Yeah, these both are carbon neutral. Why they are carbon neutral? Because even after burning that, certainly they are going to emit certain carbon to the atmosphere, but it is sequestered back in the same year. That is why it is called actually carbon neutral material. Yeah, thank you.
Thank you. Thank you, Dr. Prakash. Dr. Ruma, my next question is to you. To enable sustainable forest management that we are discussing right now, what is also important is that we enable an effective decision-making process for the right stakeholders. Where do geospatial technologies fit into this picture?
Yeah, so first thing is that why this question of sustainable management? So this sustainable concept is because there is a huge conflict between the development and environment. We want development, at the same time we need to preserve the environment. You have recently seen that leopards are coming out of the habitats and they are, even in Ghaziabad court, they can see the leopards. Why that is happening? Because of these conflicts. And now we need to see that how these conflicts can be reduced using the technology. And technology is important in forestry segment, especially because it is a wide area spanning across states, across districts. And now talking about how it can be mitigated. So Partha, Yashwant and Mukesh has already mentioned about seamless integration about satellite images, aerial photos, LiDAR data. You can also use the drone surveys over the administrative boundaries of the forest for different levels of spatial analysis. Along with that, GPS and mobile data nowadays can also help in different type of on-the-spot data collection. It helps in beat mapping, it helps in patrol routing, etc. Tools can also help in day-to-day operation, like which species are suitable in which climatic region or which type of soil that is essential. Then one important aspect is the nursery management. So how the GIS can help in the nursery management, in cost estimation of the fencing. So geotools can be developed to analyze the cost of fencing of the nurseries and the newly planted areas, different type of treatments which can be undertaken, site suitability aspect for other things also, like stabilizations of slope, or for planning different type of particular species which can be put over particular sites. For habitat planning, as mentioned, that habitat planning is one of the aspects. So we are not only looking after the flora part, but also the fauna parts need to be taken care. So habitat planning, like the WWF often takes care of the habitat planning of the elephants. So this type of habitat, so where they are moving, those areas need to be conserved, because this conflict has also led to the large number of fauna which is daily getting affected. There are a large number of animals which get accidentally killed by the railways or by the fast moving vehicles. So, this habitat becomes important in the sustainable habitat mapping and or has sustainable forest management. We also see that geospatial technology can be used in historical analysis. Historical analysis of how the forest covers has been changing, the stand inventory, how it is changing, the soil types in it. It can also incorporate the changing weather patterns and land use practices. So how the land use practices are changing from forest to non-forest area and non-forest to forest area. So that the technology can help you in or decision makers to look into this thing, that how this change in land use patterns are happening along the peripheral regions. This geospatial technology also helps you in modeling, which helps the user to test and consider the options in terms of both temporal as well as spatial components of forestry. There are few issues which can be dealt by using the remote sensing and GIS technologies, which includes the land encroachment issues. So these forest administrators can look into which are the encroached areas and how this conflict can be resolved, where these people or the villages can be moved out and rehabilitated, how much compensation need to be provided to these peoples, and how that can be, these jungles can be increased in those encroached areas. Then land conservation monitoring, as I have already mentioned, conversion of forest land to different types or reclamation of other lands to forest land. Man animal conflict zones. So technology can help in mapping which are the specific areas where man animal conflict is happening, and then we can take the decision accordingly. Technology also supports in operation management against poaching, because we can develop the incident based tools which can be used by the patrolling teams to immediately reports on the incident that can be visualized. Then again, we have talked about the forest fires. So in sustainability aspect, this is one of the most important thing. As it says, jungle mein aag. Jungle mein aag is always spreading in a voluminous ways. And technology can support in controlling that. Complete operations management of how the forest fire can be controlled can happen through technology. We can see through satellite technologies that how the forest fire is growing, and then we can take the actions, that which areas to be cleared immediately, on what type of fogging type of things can be undertaken to control that forest fires. Then there are heat maps. Heat maps can be generated specifically for the areas of deforestation inside the forested areas of encroachment, areas where the poachings are very common. So that type of heat map can be generated using GIS and remote sensing technology. Now AI has been integrated with GIS, and that can help in the biodiversity management. As Professor has rightly mentioned, that forest trees can be identified, species can be identified. So 70 to 80 species, if that can be monitored, that how biodiversity is happening inside it. And lastly, we have to also take care of the continuous activities inside the forest. So mining is one of the areas which has a complete continuous conflict. So this technologies helps to map and to continuously monitor whatever activities are happening. We can geotag these things, but that what type of activities are taking place inside it, what type of construction activities are happening, and we can plan accordingly that how that can be mitigated with limited impacts of these activities on the forest cover. That's all from my point of view on
Thank
this
you.
question.
Thank you. Thank you, Dr. Ruma. Mr. Mukesh, my next question is for you. Our forest ecosystems, they are so dynamic and ever growing. And to study their development, it is very important to study them in respect to the spatial data. Now, our other speakers have already touched a little about forest ecosystems and biodiversity. I would like to know more from you. What role can forestry mapping play in this regard to study our forest ecosystems better?
Yeah. So Sakshi, talking about the forest ecosystem, right? So this is one of the biggest ecosystem which we can just look into and analyze, because forest ecosystems plays a very key role in the environmental health of the country. So as Professor also was mentioning earlier, actually, in India, we are talking about almost 80.9 million hectares of forest cover area, which is almost one third of the total geographical area of the country's landmass. Right. So forest ecosystem is a very large and complex ecosystem which comprises of trees, soil, various forms of life living in it, animals, birds, insects, and humans who are also using forest as their habitats. And so forest plays a significant role in maintaining the overall health of the environment, like controlling the water cycle, stabilizing the soils, keeping the climate under control, right? And also providing habitat for the wildlife and livelihood for several communities, forest-based communities living in and around the forest. So with this kind of an ecosystem, it is very much essential and responsible for us to conserve, right? Because this is very important, wherein we are reaping direct and indirect benefits out of this forest ecosystems. And yes, definitely the geospatial technologies, the several geospatial technologies that are available are play a crucial role in each of it contributing towards giving certain data sets, different types of data sets which are used for different applications, right? So we also should closely look at what are the threats or risks that are being posed for this forest ecosystem, right? Like as I earlier mentioned about the floods, the droughts, which the flood which initiates or which sparkles, the landslides, the soil erosion, the degradation or desertification kind of effects. So, and also one of the key challenges are the encroachments these days. Actually, we see a lot of, forest areas are being encroached, illegal mining activities are happening, and then there's a lot of illegal deforestation and several developmental activities that are happening within the forest. So, how do we mitigate these potential threats, and how the geospatial technology helps us in mitigating these risk factors is very crucial. So we are using several tools like GIS, remote sensing, and also field survey techniques to go to the ground and then carry out the survey and analysis for studying the various forest parameters. Now, as I mentioned earlier about the advantages or the benefits which the LiDAR technology can give us to create a high accurate and precise forest map, wherein we can get several thematic layers to study the health of the forest and several parameters to also monitor the illegal developmental activities that are coming up, the illegal mining activities, the gaps in the land fall, right? And some of the important applications where the geospatial technologies can really help is identifying the open areas where afforestation can be concentrated on. And somebody was asking about the tree analysis. Yes, we can get tree height, tree volume analysis using this geospatial technology, and the soil moisture conservation, the watershed analysis. Okay, and we can also, with the help of the revenue records, we can identify the land boundary We can demarcate the boundary of the forest and see to what extent the encroachments have taken place. And then the elevation, the slope analysis, catchment area mapping, forest fire control. Yes, what is triggering? What is the point that is? In the advantage of using other different multiple data sets, like as I mentioned earlier, along with the LiDAR data, the point cloud, we also get imagery where you get the RGB values and also the infrared details, using which you can see the health of the trees and also the soil parameters. And this will definitely help us to do the estimation of carbon stock also in the forest areas. One more point I would like to cover actually, which is regarding the vegetation density and biomass. So how this LiDAR technology really helps us in getting precise estimates of the vegetation density and forest biomass analysis. Because as as I mentioned earlier, LiDAR gives us the point cloud density, actually, right? The point cloud and the density of this point cloud, I'm talking about 10 points per square meter. Now, that's the kind of data, the information that I'm getting from my LiDAR point cloud. And then we have the aerial photography, which is captured alongside, which is of, we can capture up to a better and high resolution of 5 centimeters also, depending on the type of the requirement. Now, with this both data sets in hand, so we can precisely, do the vegetation density in the forest. So forest cover is categorized into 3 density classes, like very dense forest, which is having more than 70% of the canopy density, moderately dense forest with 40 to 70%, and open forest with density between 10 to 40%. Right. So now the LiDAR technology gives us more accurate information for measuring the vertical structures of the canopy and its density. So these models will help us in understanding the complex forest structures and also generate accurate forest inventory. Right. And LiDAR technology in that sense is very effective in terms of time and cost and accuracy of the data, because the laser pulses have the capability to penetrate the forest canopy and give us the exact, the girth, the height of the tree actually. So this will help us for the forest biomass also. Just to give a small example of how the forest carbon estimation is being done. If you take a single tree as an example, right, the ideal sense would be to go to the ground and then cut the tree and then weigh it. But then that's not practically possible for us to do at the larger scale. So that's the reason we have the researchers have developed an equation called as allometric equations, so which would precisely estimate the biomass. So these equations link the measurements by taking the parameters like the tree height, the stem diameter, and wood density. So thereby, through the analysis, we'll be able to estimate the biomass which is intact in that particular tree. So the LiDAR data can precisely give us these parameters, which can be used in these analytical tools and modeling softwares, and thereby get very high accurate and precise results also. So thereby, yes, the forest ecosystem, which is ever growing, needs to be preserved, conserved, and technology has to be put to the maximum use of it to reap the benefits. Thank you, Sakshi.
Thank you, sir. Mr. Partho, my next question would be to you. This month, the Forest Survey of India has already recorded a 115% increase in forest fires in the country. Around 42,799 forest fires have been detected between March 1 and March 12 alone. Now, while other speakers have already touched upon this topic a little, I would like to know more in detail from you how geospatial technologies can be leveraged to monitor, assess, mitigate, and predict forest fires for better preparation.
Thank you, Sakshi. Here I'd like to mention that throughout my career, I am working with remote sensing technology. And in remote sensing, there is a very, very common phrase we always use, that is, you can't fix what you can't see. That means to fix any problem, first thing is required, that is, you have to see the problem. So what is the conventional source of seeing the problem? That is the human intelligence. Now, as I was searching in the internet, and I found that India has around 81 million hectare of forest area. So now getting the human intelligence from this vast area, how much difficulty it is, that we know very well. So another option remains, that is the remote sensing. So that remote sensing may be optical remote sensing, maybe SAR, maybe LiDAR, maybe drone, maybe synthetic aperture radar. So any kind of remote sensing may be the solution. So remote sensing may be used very effectively during this situation, because when the fire has started, you cannot go to the fire area, because but we have to know how much area is impacted, what is the severity of the fire, and we have to track the behavior of the fire, and what is the probability of the expansion of the fire. Sometimes it may require the human evacuation plan needs to be chalked out. So these are the things can be done very effectively using satellite imagery, and across the globe it is happening. So thing is that, as I have already mentioned in my last time, and Professor Om Prakash already mentioned, we need the very high resolution and high frequent imagery. For example, forest, I have the example, I have some site in Bangladesh, which is very near to Tripura, just a border area of Tripura and Bangladesh. There was a fire started in a day, and in the next day, few hundred square kilometers is completely burned. And government authority, Bangladesh government authority did not have that information at all. But if they have the satellite information, so that is satellite alerting system, so definitely they will get this kind of information. Okay, that is possible. So it can be possible through thermal imagery. So whatever the, when there is a fire, that definitely the heat will be increased, that can be captured by thermal imagery. So normally MODIS data used very widely, very frequently by the different forest management organization, because MODIS data, although it is moderate resolution, it is a few hundred kilometers of resolution, but it is used everywhere. Next option is there, that is the that we use normally, that is the Sentinel one, that is 10-meter resolution, but it is available in 5 days. For example, if something happens today, we'll get the information after 5 days. Private space company like Planet Labs, where I'm working, so we have daily imagery. So in every 24 hours, user may get the freshest imagery of across the globe, that means across the forest area. We have higher resolution, sub-meter resolution imagery also, so that is available on a sub-daily, that is on demand basis, it is available. So sometimes it is also required, that is the, if fire has been started, you need to extract the severity of the fire. So differential normalized burn index kind of indices can be used to identify the burn severity. Forest fire prediction, yes, I would like to take 1 minute time on forest fire prediction, because as Professor Om Prakash already mentioned, that is the hyperspectral imagery and firewood identification. It is very much important for forest fire prediction. And I was seeing the various scientific publication using this firewood identification. So how they are using? So they are using hyperspectral imagery normally to identify the greenness indices like NDVI, EVI, modified soil adjusted vegetation index. At the same time, they are extracting some water canopy index like disease water stress index, leaf water vegetation index, and so on. Normalized differential water index. And at the same time, dry carbon index they were using, that is cellulose absorption index or lignin index they were using, and combining this greenness index, water index, carbon index, that is firewood identification is possible. It is various publication I was seeing. And previously I was working with the quartz products. In that particular quartz product also, there is a ready-made tool to identify the forest fuel wood identification. So that can be done. So that's the way. So here I would like to mention that in remote sensing data can play a very crucial role for prediction of the forest fire, early detection of the forest fire, forest fire behavior monitoring, that means which direction the fire is going. So that maybe wind may be one of the major trigger for this, and post fire assessment if required. So all these things can be done using satellite remote sensing. Shakshi.
Thank you, sir. Thank you so much. Mr. Yashwant, coming back to you. forest wetlands are very valuable ecological systems, but are equally complex habitats to manage. Now, while remote sensing has long been used for wetland mapping, what potential do you see for other emerging technologies like drones, 3D modeling, deep learning, etc., how they can contribute for forest wetland mapping and studies?
Thank you, Sakshi, for your question again. Well, not only the satellite data sets, but the other approaches like the drones, the 3D modeling via the technologies, the deep learning, AI, they all can contribute. Of course, they can contribute. And as you described, the wetlands, they are among the Earth's most diverse and the productive ecosystems. We know that. So, what are the things which are affecting those wetlands? They are affecting. They are facing the problems with the population. They are facing the problem with the urbanization and the industrializations, and with the various other human activities. With the help of these technologies, like if you do have the very high resolution, or we can say the ultra high resolution drone data sets, or you do have those machine learning algorithm with you, they can help to study the spatial and the temporal assessment of that particular area of the wetland, and we can identify and we can monitor the impact of those activities on the wetlands. This is the number one thing. Another is while using those high resolution data sets from drone, or even using the open source satellite imageries, we can do the classification, or we can say the categorization of the land, what we call normally the land use land cover maps. So these maps are also helpful to analyze the possible impact of the human activities on the wetlands. After that, the GIS helps to define the wetland boundaries, as we are saying it regularly, that remote sensing helps to demarcate the boundaries of the forest. It can helps to demarcate the boundaries of the wetland as well. The pre-monsoon and the post-monsoon water spreads can be calculated, can be demarcated. The aquatic vegetation can be demarcated with the help of these high-resolution data sets. Along with this, we do have these remote sensing data sets with us with the help of their processing. We can. It's a very common thing, but they are yet very effective. We can create various indices with the help of these data sets, like the vegetation index, like the pond index, the turbidity index. They can help in the quality analysis of the various factors which are responsible for the management of the wetlands. Along with this, if you do have those sensors which can give us the bathymetry data sets, they can help us to analyze, to study the sediment accumulation which is happening there into the wetlands, and some very traditional and the common products like the high resolution orthophotos, the digital terrain models, the digital surface models. They all are contributing in the better management of the wetlands.
Thank you so much, Mr. Yashwant. Now, my final question of today's session goes back to Dr. Om Prakash, and probably one of the most important considering our audience profile today. India's forest cover is being biennially monitored using remote sensing technology, and detailed reports are brought out by the Forest Survey of India. I would like to understand from you how this information can be leveraged by officials at the grassroots level for effective forest management. If you could please share your thoughts.
Yeah, very good. Question C. At the grassroots, I believe that your question is towards GFMCs, Joint Forest Management Committee managed area. Okay. Yeah. When we talk about the grassroots GFMC level, we are talking about something roughly around something 500, 400 hectare area, a compartment or maybe more. So in any case, it is less than 10,000 hectare area. So the Forest Survey of India still they are relying on using the IRS data, which is still 23.5 meter. That is what the data they are using. Because for them, it is important to provide that the more rigorous data with temporal dimensions. Means every second year, they have to produce the change detection of forests of the country, entire country. So it means that to relying on this 23.5 meter, I think probably it is serving the purpose at the most at the district level, not below that. That is the biggest problem. So for the grassroots level, they have another approach that is called forest inventory approach. So this is being carried at the zonal office level. So they have the various zonal offices. So they have a 10-year cycle. 10-year cycle means they are using the ground-based inventory, and which is again been equipped supported by the remote sensing data like aerial photogrammetry. They use the aerial photogrammetry for stock map of the entire country, which is of 10-year cycle. I don't know, still they are continuing with that approach, because when I was, because I left this organization long time back in 93 December, till that time even I was involved in making stock map of the entire country. So which is integrated approach. Basically, at the top level, it is the aerial photogrammetry, using the aerial photogrammetry to produce 1:10,000 map of the country of 10-year cycle. Same time, also do the mensuration of the forest, that is doing the stem density and the volume assessment of that is growing stock assessment of the entire country. So that was the approach. Now what is happening with the Forest Survey of India is that they have that what is called inventory, that is sample check they are doing, inventory they are doing it, and they are relating it with the what is that biannual, that is the 2 years interval report of forest change assessment. Basically, they say that India's status of forest report, their major emphasis on what has changed during the last 2 years, whether the forest has been increased or decreased. So that is how they are working in that, and they have also expanded their activity to now the tree resources outside the forest. Even that also as a bit the small resolution, like they are taking anything area more than 0.5 hectare has only been mapped as a tree resources outside the forest. Again, they have a disadvantage, like in India, like when you talk about the TOF, tree resources outside the forest, which is more is scattered in nature rather than they are in a block or in what is called that in a clustered one. That is again a disadvantage. But anyhow, time being, they have the 0.5 hectare more area is mapped as the tree resource outside the forest. Same thing that taking the 23.5 meter or roughly 24 meter by 24 meters visual resolution as the forest area. That is how they are taking. They are taking it as a mapping one. So when you talk about the grassroots, that is at the forest, joint forest management or the compartment level, there are two issues when you use this data in the field level. One important is that you know that the compartment map itself has lot of spatial integrity problem. Now the state itself is regenerating their compartment maps. Still, they are in the process of regenerating it to make it more geospatially accurate. So many states went for now GPS differential, using differential GPS to map and make this compartment precise. First thing. Second thing, when you use this such a small resolution, when you compare it at the grassroots level, I think probably it may not serve the purpose of what there is. When you talk about the grassroots, they need the three purpose. One is the age of the forest. Second one is the density of the forest cover. Third one is the what is called the diversity of the forest. These three are important. All these three are lacking in the forest, that is India's status of forest report. So in the overall, my opinion is that using this as only a baseline information at the grassroots led to produce more or add-on information related to the stock of the forest at the compartment level, that is the age, diversity, that is forest type and the diversity, and also the density. So when you talk about the grassroots level density, it is not talking about the canopy density. There they are talking about the stem density, because for them growing stock is more important than the canopy density. So that is why in the forestry, as I mentioned, what you do at the planning level, what you do pursuit at the grassroots level, there's a lot of difference. There is lot of difference in it. We need to understand the very objective of forest management at the different level. That's what my conclusion.
Thank you. Thank you, sir. Now, I can see our chat box is already very active. So any of our panelists would like to take up any question from the chat box and elaborate on it further, or if any other attendee, if you have questions, you can just drop in the chat box. So the panelists, would you like to take up and elaborate on any of the questions that are asked?
Some of the questions I have already answered with my experience in using because here in the forest, it is not like Forestry of India. I'm working in Indian Institute of Forest Management. Here we need to teach a lot of subjects. So hence not able to focus. Now rather I stopped teaching this geoinformatics these days, because I have been asked to do work on various other, with my experience, contributing to the various other subjects. So, but yes, some of the participants have answered nicely, but I also answered it already in the chat book. Even I put one question actually. There is one question actually, someone take out the panelists, respective panelists. That is something actually very coming in a very big way is the forest hydrology, which very hardly practiced or addressed by the remote sensing specialist. Especially 2-3 things. One is that water use efficiency in the forest, which is hardly answered anywhere in India. Why it is very important? Because our rivers are drying up and not much water being yielded by the forest area. Unless we understand water use efficiency in the, especially in the plantation forestry, we are not going to get more water from the forest. That is the biggest problem. So we need to address that. I'm thinking of taking this study. Let me see that. And one more question to this ESRI people like that. So there is something actually, soil moisture index has been calculated just by taking NDVI. In my experience, which is not correct. Why it is not correct? We all understand that if you have a very young tree cover with rigorous growth, where soil moisture is always poor. But if you take the NDVI and arrive the soil moisture, which is not really proportional to the what the moisture you get it in the soil. That is what. So you need to actually include many more parameters. Just taking one NDVI to arrive the soil moisture index, which is not correct, because which I did it. I collected soil samples and I analyzed it, and I have seen that moisture is more in open forest area with more ground biomass, especially the grass and herbs, than the very dense tree canopy. That is my observation. Something need to be done to get some kind of realistic data which really help the forestry sector. We have to work more for Indian forestry rather than translating some of the things algorithm developed in the temperate forest, which may not meet our purpose.
Sir, here regarding the soil moisture, I'd like to just add. In my company, we are using a technology that is a patented technology. Here we are using the passive microwave satellite, which are openly available from NASA, from JAXA, from European Space Agency. That is the passive microwave remote sensing data that we are using, and using our patented algorithm, we are generating the soil moisture. And this validation for that particular soil moisture data, which is available, it may be on daily basis as well. So that is validated by the different part of the world. And India, specifically in India, that validation was not done. So if we approach formally, in that case, if you kindly if you just try to validate certain
Certainly.
value.
Yeah, that's right. Thank you very much. Yeah, we will look forward to, because especially this CAMPA and also increasing this climate amelioration by going to increase the more carbon sequestration in the forest, which is going to be a conflict of interest, both water as well as this carbon sequestration. It is going to be because the land available is very limited, and in that you have to sequester more carbon, same time you have to produce water also. It is conflict of interest. I think this technology has to work more specific to the country requirement, and so that the sector will really receive it well and appreciate well. That's my request actually.
So, you have you put one question, that is water use efficiency in plantation forestry. That means
That's right.
you
Same.
mentioned specifically for planted forestry, that is which is
Forestry,
or
plantation
natural.
forestry, which is the age less than 15 years, because you know that some of the species they transmit more water till it reaches some maturity level. Like eucalyptus may reach at 9 years, but where the teak will take up to 30 years. So use efficiency is very important, especially in the semi-humid area. Because in the dry area, it is not of much problem because the most of this plantation is the high relief area. But when you talk about the semi-arid area, it is of some issue.
Okay, sir. Thank you.
So I would like to clarify a doubt which one of the participants had raised regarding the aerial lidar technology. So they were telling that there is a limitation with this technology in terms of the penetration when there is a dense tree canopy. Right. So in order to understand the LiDAR technology, so here we have different types of LiDAR platforms which we can use, like aerial LiDAR, mobile LiDAR, terrestrial LiDAR. But when we are talking about mapping a forest, we're talking about huge area. We have to map huge area. These days, we also have drone-based LiDARs also. But then when we are looking at huge volumes that needs to be mapped, and also depending on what type of application for which we are carrying out the mapping actually. So one advantage with the aerial LiDAR technology is that when we mount these high frequent, high precision range airborne LiDAR sensors in the aircraft, so depending on the type of application or the type of data that is required, we do something called as mission planning or the flight planning. So we earmark the area of interest, and then we see what should be the density of my LiDAR point cloud, what should be the resolution of my imagery that I'm going to capture. Based on these parameters, we decide the altitude and the flight lines of the entire area of interest coverage, right? So based on this mission planning, so we decide the altitude, and when we fly at lower altitudes, my LiDAR point cloud emission is at very it's at a larger scale actually. More dense points are emitted, and the possibility of getting the reflectance back also is very high at lower altitudes, right? Now the question arises regarding the dense canopy locations where there would be limitations in terms of penetration. Now the advantage with the LiDAR is I will get my returns of the LiDAR point at multiple levels, right? The first return that I get after the LiDAR points are emitted is the height of the tree, which is the tree canopy level. Then I get second return, third return, and then something called as last return. The second and third returns would be at the intermediate levels of the tree, the branches or the stem, or anywhere at the mid branch level something. Now, when I say that last return point, that is the point which hits the ground surface and it returns back. Now, the density that I'm talking about is 10 points per square meter. Now, let us say I'm not getting 10 points per square meter. I'm getting only 2 to 3 points per square meter. Still, with that density, I will be able to precisely classify and create a three-dimensional digital elevation model of the bare earth surface. So that would still yield my results when it comes to accurate contours and watershed analysis or runoff analysis, okay, or mining volumetric analysis. That will suffice. Now, coming to the other application where I'm talking about the tree itself, the height of the tree, the crown density or the width of the crown, the girth of the tree, all this will be captured using my LiDAR point cloud. And we have over the years developed these algorithms, and also we have LiDAR experts who will be able to classify the data and give us the results. And alongside, we also have an aerial photograph, right? So each photograph will be able to distinctively tell us the type of the species that we're looking at. That signatures can be captured, right? So, if I have to compare this with other technologies, I would be left with only remote sensing technologies with which I'll have to compare. But remote sensing technologies, they have their own advantage in terms of giving us the time series data, giving us the larger data at a shorter time, right? So I think each technology has its own advantages, and depending on type of application, we deploy the technology. Thank you.
Thank you so much. I think the kind of breadth and depth that this subject has, it will be very difficult to limit our discussions to just a 1 or 1.5 hour session. But I think that we've still done good justice to the topic, and it has been very interactive, engaging, and very informative. And truly, it has been a knowledge session for all our participants, panelists, as well as the organizers. And so, on behalf of all the attendees and on behalf of the AGI Secretariat, I would like to thank all our panelists for joining us today and for making this session such an interactive and a successful one. And I also would like to thank the attendees for joining us and for being so interactive in the chat box and putting in their questions. And yeah, thank you all. And I think we can conclude that geospatial technology is very critical if we want to realize the vision of sustainable forest management in the country. And we really hope that going forward, discussions like this translate into more adoption and awareness of the technology, and it can just pave the way for this kind of vision. So again, thank you all, and looking forward to engaging with you further again at some other opportunity. Thank you.
Thank you very much. Yeah.
Thank you, Sakshi. Thank you, AGI, so much.
Yeah, pleased to meet you all. Yeah, thank you very much.
Thank you
Thank
very
you.
much, Sakshi and AGI and all the co-panelists and participants. Thank you very much.
Thank you.